Good evening, class, and welcome to Lesson 3.7, Estimate Decimal Sums and Differences. Let's begin by taking a look at our essential question. How can you estimate decimal sums and differences? Well, let's try to answer this question by taking a look at our Unlock the Problem. A singer is recording a CD. The lengths of the three songs are 3 and 4/10 minutes, 2 and 7/800 minutes, and 4 and 1900 minutes. About how much recording time will be on the CD? So we're going to use rounding to estimate. And remember, to round a number, determine the place to which you want to round. If the digit to the right is less than 5, the digit in the rounding place stays the same. If the digit to the right is 5 or greater, the digit in the rounding place increases by 1. So we're going to round to the nearest whole number, then add. So for rounding to the nearest whole number, we are rounding to the first digit to the left of the decimal. So we are rounding the 3, the 2, and the 4. So in the 2 spot, we need to take a look at what is to the right. And we see that what is to the right is a 7. And over here, we see 5 or more raise the score. So 2 raised by 1 becomes 3. Then we have our 4. When we look to the right, we see that the digit is 1. And it says if the digit to the right is less than 5, then we let it rest. So we see that 1 is less than 5, so our 4 stays the same. So when we add those together, we know that 3 plus 3 equals 6, and 6 plus 4 equals 10. So there will be about 10 minutes of recording time on the CD. Now, it says to try this, use rounding to estimate. Round to the nearest whole dollar, then subtract. So we're rounding to the nearest whole dollar, which we are going to look at the first number or the number in the ones place value to the left of the decimal point. So when we look at the ones, we see that we are rounding our 7. So in order to round our 7, we need to look to the right, and we see that is 9. So that is 5 or more raise the score. So our 7 increased by 1 then becomes an 8. And we bring our 2 over and drop the numbers to the right of the decimal. Then in our next one, we see that our 1 is in the ones column. And if we look to the right, we see that we have a 7. Well, 5 or more raise the score, and we see that 7 is greater than 5. So our 1 increases by 1, and then it becomes a 2. We bring our 1 over and drop our numbers to the right of the decimal. So then we add or subtract those. 8 minus 2 is 6. 2 minus 1 is 1. So to the nearest dollar, $27.95 minus $11.72 is about $16. So it says to round to the nearest $10. So this we have to find what place value we're rounding. So we're rounding to the nearest tenth. So we are looking at our 2 and our 1 in our tens column. So to round our 2, we must look to the right, and we see that we have a 7 to the right of our 2. So 5 or more raise the score. 2 increased by 1 then becomes a 3, and we replace all the other numbers with zeros. Now, in our next one, we look at our 1 and we see, look to its right, and we see we have another 1. 5 or less, let it rest. So we leave our 1 alone and replace all the other numbers with 0. So 0 minus 0 is 0, 3 minus 1 is 2. So to the nearest $10, $27.95 minus $11.72 is about $20. So do you want an overestimate or an underestimate when you estimate the total cost of items you want to buy? Well, you definitely want an overestimate to make sure you have enough money to buy the item. If you underestimate, you may not have enough money to purchase all the things that you want. Let's take a look at another example. It says to use benchmarks. Benchmarks are familiar numbers used as points of reference. You can use the benchmarks 0, 25 hundredths, 5 tenths, 75 hundredths, and 1 to estimate decimal sums and differences. Example 1 says to use benchmarks to estimate 18 hundredths plus 43 hundredths. So locate and graph a point on the number line for each decimal. Identify which benchmark each decimal is closer to. So if we draw out our number line and we place our 18 hundredths on there, we know that 18 comes before 25, so our 18 hundredths is going to come before our 25 hundredths, so it is closer to 25 hundredths. Now, our 43 hundredths, well, we've got 1, 2, 3, 4, 5 in between. So we know that we're going to have to go 1, 2, 3, 4. So our 43 hundredths is going to be right in here somewhere. So let's place a dot really close to where we think the 43 hundredths and label it as 43 hundredths. So 43 hundredths is between 25 hundredths and 50 hundredths, but it is closer to 50 hundredths. If we look at our number line, we see that we are closer to 5 tenths than we are way down here to our 25 hundredths. So when we round those using our number line, we see that 18 hundredths rounds to 25 hundredths, 43 hundredths rounds to 50 hundredths. So when we add those together, we get 75 hundredths. So 18 hundredths and 43 hundredths is about 75 hundredths. Now our example 2 says to locate and graph a point on the number line for each decimal. Identify which benchmark each decimal is closer to. Well, remember our benchmarks are 0, 25 hundredths, 50 hundredths, 75 hundredths, and 1. So we have our first one of 75 hundredths or 76 hundredths. So we know that we have a benchmark of 75 hundredths. So our 76 hundredths is just going to be one little tally away from our 75 hundredths. Then we look at our other one. We have 22 hundredths. Well, we know that one of our benchmarks is 25 hundredths. So we know that our 22 hundredths is going to be really close to our 25 hundredths. So we will place it like right there and we will label it. So 76 hundredths is between 75 hundredths and 1, but it is closer to our 75 hundredths. Now our 22 hundredths is between 0 and 25 hundredths. It is closer to the 25 hundredths. So when we're rounding, our 76 hundredths becomes 75 hundredths, and our 22 hundredths becomes 25 hundredths. When we subtract those, we end up with 50 hundredths. So 76 hundredths minus 22 hundredths is about 50 hundredths or 5 tenths. Now let's take a look at our problem-solving problems on page 134. It says to use the table to solve 17 through 18. Well, we're only going to use 17. It says to show your work. So for the week of April 4th, 1964, the Beatles had the top 4 songs. About, that is going to be a key word, how long would it take to listen to these 4 songs? So we have song number 1, Can't Buy Me Love, is 2 and 30 hundredths minutes long. Song 2, She Loves You, is 2 and 50 minutes, 50 hundredths minutes long. 3 is I Want to Hold Your Hand, is 2 and 75 hundredths minutes long. And song 4, Please Please Me, is 2 minutes long. So if we estimate those, how long would it take to listen to these songs? And we are estimating to the nearest whole number. And remember, our whole number is to the left of the decimal, to the left, to the left, to the left, to the left of the decimal. So go ahead and give that problem a try on your own, and make sure you record your answer in your book and bring it with you to class in the morning. I will see you then.